Okay, so we're 1.5, analyzing graphs of functions. You have that written down from yesterday. We are going to do more range. We are going to do more range domain. We're going to evaluate. Hopefully it starts coming back really quick because it needs to. Okay. So, yesterday we started with this one. It says what is the domain, what is the domain of the f, what is the value of f is -1 and f is 2. Now I had a couple questions about b and we did it yesterday, so that's what really baffled me. We did that. Okay? So what is the domain of this graph? Again, I'm not going to write it down, you should have already written it down. It is not all real numbers.
X such that...
No, look at the, don't read it off your paper. What is the domain, guys? -1 to what? 5. Is 5 included? No. How do you know? It's open. What is the range?
3 to negative.
-3 to 3. Is it included?
Yes.
Yes. Okay. What is f of -1? Well, it's usually f of x, yes? What's x now? -1. So you do what? You go to -1, right? X is -1. And what is the answer? 1. F of 2, what do? You go to 2. And then it goes to what? -3. What's the range? Oh, we already did the range. Okay, do this one on your own. I'm not giving you forever. I'm giving you like a minute. Maybe 2.
How do you do that? There's 2 separate lines.
You're going to have a break in your domain, aren't you?
Well, I suppose.
Try it. I want something written on your paper.
Yeah. Alright, done.
It just says hi. Help me.
If you don't know how to use domain no range, should you be able to do f of -1 and f of 2?
Yeah.
Yes. So do it. If you're stuck on domain, go to B. Everyone should be able to do B. Kendria, what'd you get for domain?
No, not really right. But
Okay, that's fine.
Negative infinity to infinity.
Okay, so it's not all real numbers. Can anybody tell me why it's not all real numbers? Kale.
Because you can't go to 0.
You can't, there's a big old gap.
Yeah.
Yeah? You see that?
Yeah.
Everyone see there's a big old gap? So it's negative infinity to what? -2. So x, -1, excuse me. X is less than equal to -1 or what? Or greater than equal to what? 1. Now you could write it in interval notation and you would have to do negative infinity, -1, bracket, union, 1 to positive infinity. Now, if you do interval notation, that's a horrible parenthesis. If you do interval notation and you don't put the u, you're going to lose a point. If you don't write it correctly, you're going to lose points. So if you insist on interval notation, you've got to use the bracket, you've got to use the parenthesis, you've got to use the union. Understand?
Yes.
Okay, so f of -1 is what?
0.
0. When f is -1, what is y? 0. See that, Elena?
No.
Okay, let's do it again. This was f of x, yes? So x became -1. So when you go on the graph to -1, what is this point right here? What's the coordinate of that point? -1 what?
0.
0. So your answer is 0.
How's it 0?
You just said it's -1, 0. So this is your x, so that's your y. What did you have?
I have -1 because that's what it's on.
Okay, but -1 is the x. I gave you the x. I want the y. Okay? So let's try this one. Elena, let's try 2. F of 2. What's your y? So it'll be right here. What would be the coordinate right there?
2.
2. So f of 2 is 2. Okay, range. Evan, range.
I didn't have
You didn't have the range?
it. No.
Brad, you have the range?
Yeah.
Okay, what do you got?
Range is y is such that y is greater than or equal to 0.
Y such that y is greater than equal to 0. And you are correct. Does everyone see that?
No.
How? What?
I don't.
Okay, so 0 is my smallest, yes?
Yeah.
Okay, and it does what?
Go up.
It goes up. Now, there's no dot, there's no point,
Yes,
so the assumption that this graph goes off the chart.
forever.
Does that make sense?
Yes.
Okay.
I have a question.
Yes.
Okay, I just want to know if my thinking is right. So I think like, so the 0 like is as low as you go is 0, and then like, I think of like y going the other way, and if it can like keep going, then it's like it's bigger than it, so it plays facing it. Like is that like? I don't know. Is that
Oh, are you talking about for the inequality? Or what?
Yeah. Wait. Yeah.
Yeah?
Yeah.
Okay. It's always facing the bigger thing. It's always open to the
Yeah.
bigger. And when
So-
when like books, like multiple choice will say greater than or less than, they're talking about comparing the left to the right. Textbooks always compare, or tests, they always compare the left to the right. But when we write them, because I could have written 0 is less than equal to y. It would be the same thing, wouldn't it?
Yeah.
So it just, when you write it, make sure it's always open to the larger one. But if you're looking at the textbook, they're always referring to left to right.
Okay.
Make sense, everyone?
Yeah.
Okay, and that took me forever. Like, nobody ever, they're like, is it greater than or less than? I'm like, I don't know. Well, it's open to the bigger one if you're writing it. But when a textbook does it, it's always left to right, comparing. Okay, there is one more. And I want you to do this one too. Oh, wait, there isn't one more. Well, it is and it isn't. We can do the domain and range. Go ahead, do the domain and range. And this one gives you 4 that you need to do.
Just number 9.
I don't know.
I think it is number 9.
Oh, okay. I can't help you on a test. Yeah, we already established that. Okay, do it anyway. Brad, do you need the light off back there, or can you see it well enough?
Oh, it just kills fat head.
Is there any glare? That's all I'm asking. Okay. How did you guys do?
I think I got all of them right. I just didn't do the domain and range. It took me how long to do the A through D.
I have a question about the range.
Okay.
Why is it not like two different ones? Because it's -2, then there's a gap between.
Yeah, but your Y, am I covering all the Y's?
But it overlaps.
Like, am I cover? Well, it doesn't overlap because this is,
But it like hits it.
yeah. So from -2 on is every single Y accounted for.
Oh, yeah.
Do you see that? And it's only a function because it's included at 1, like at 1 it's 1. That's one of the answers, right? F of 1 is 1. Why is it not -2? Because there's what?
Because
Open circle, so it's not -2. If at F of 1 was 1 and -2, would this be a function?
no.
No, because it wouldn't pass the vertical line test. Okay? Yes?
How come the last one had the x was less than or equal to 1, but that one for the domain is all real numbers? For this?
Because the domain is like, the domain in the last one we had a gap. Like, we didn't use anything between these two numbers on the last one. Like, it went like this. Like, there was a gap in here on the last one. This one, as I draw all over it and you can't see, this one, it's not, there isn't any gap. It's in the domain. I'm using everything, and I use 1 here, but not here, so I'm good, and I keep going. Like, everything is being used. All my X's are being used. There's actually no physical gap on the X's.
All right.
Does that make it clear? That was a good question. Okay.
That one is confusing.
It is kind of. Yes.
For F of 1.
Yes.
I put -2.
Okay, why is it not -2?
Well, I don't know. I put -2.
What? Look at the graph again. Why is it not -2?
So,
It's open. What does open mean?
Not included.
Not included. Okay, any others before we go on? Okay. So, vertical line test, you do not have to write all those words. That is out of the book. When you see things in frames like that, I'm going to put them there and we're going to talk about it and you're going to write what means something to you. You got it? The reason why I put it there is because you need to learn from a textbook. And when you read things from a textbook, you probably don't want to write down every word, especially in a math book, because you need to write out what makes sense to you, correct?
Yes, ma'am.
So what is the vertical line test? Not reading that. What is the vertical line test you know in your, Isaiah?
When you draw the line, if it passes through only one time, it's a function. If it passes through more than once, it's
Not a function. Okay. So if it only passes through one time, what does that say about it? It is a function, yes. But it says every x has what?
1 Y.
1 y. So that's one thing. If you guys, if you can't tell me what's the vertical line test tell you, what's it tell you? Every x has what? 1 y. So you need to know that. Yes, it's a function, but what makes it a function? Every x has what? 1 y. You don't need to draw that, Kendria. She's drawing the circle. She's practicing her circles for next semester. Okay, so in there, okay, now their definition of vertical line test for a function is a set of points in a coordinate plane is the graph of y as a function of x if and only if no vertical line intercepts the graph more than 1 point. Okay? That's a lot of words to say it can't hit more than once, right?
yes.
Now, I want to explain this because you had a question in your homework the other day. It was said, is h a function of t? Okay? So that means I put in t and I get out h, yes?
Yeah.
And it was, because it was a parabola. And then it says, is t a function h? Well, if t was a function of h, you would turn that parabola on its side, wouldn't it?
Yeah.
And would that be a function?
No.
No. So that's that 1 to 1 we talked about last year also. or you could have just did a horizontal line test and then it would have failed that. So when it says y is a function of x, that means you plug in an x and get out a y.
Why?
Is that the function?
No.
No.
No, what is it?
Okay.
A circle. That is an equation of a circle. X squared plus y squared equals r squared. We've talked about that. We will continue to talk about that, but when you see it, you should say, oh, that's a circle. Because both x and y are what? Squared. Yes.
Is that? I understand like all the points are like the same, but why does that look more like an oval?
Just because of the picture.
It's fine.
Mine, actually, I can tell you why. On mine, it is a circle. When it projects, the screen is being brought out, so it's bigger for you guys to see. But like if you look on mine,
Oh, okay.
it's a circle. It's just the projection. And that's why we don't trust pictures. We trust the numbering. We don't trust the drawer. Okay. So, zeros of a function. This is something you need to know. It is one of the most important things you will ever do, and you will always do it in math. That's like the goal. Haven't you like solve it? Yes? Okay. Solutions, x-intercepts, and zeros are all the same thing. A zero is where it crosses the what?
X-axis.
X-axis. A zero or function f of x are the x values for which f of x equals 0. Well, add an x-intercept. What is the y every time?
Intercept.
No, what's the y every time? 0. That's why f of x equals 0. So zeros, what was another name I gave it?
Solution.
Solutions
And x-intercept.
and x-intercepts. You need to know that. Anything I ask of those three, you're going to find them exactly the same way. You are going to write x-intercepts differently. How do we write an x-intercept? Do you guys remember? Do I write x equals 6?
No.
No, I put 6, 0. I write it as a point, right? Because an x-intercept is a point on the graph.
Yes.
So, how am I going to find the zeros of this function up here?
Set it equal to 0.
Set it equal to 0 and what, Isaiah? Factor. Have you done that over and over and over and over?
No.
Okay, so 0 equals 2x minus 7x minus 30. I'm going to give you a minute to start that. I'm getting there. It was actually like right there. That's why I wrote those down. Okay, so you should have 2x plus 5 and x minus 6. And it was taking me a second. Ethan helped me out. I was right there.
Until I help.
Can anybody figure out what was I doing over here?
I know.
What was I doing?
Trying to figure out.
Do I?
I was 60 is 2 and 30, yes?
Yeah.
And 30 is 3 times 2 times 5.
Yep.
So now can I move 2, 3, 5, 2, 3, 2, 5 around, multiplying them to get what I was getting at?
Yeah, but
Yep.
that's much
Where did 3 go?
Well, 2 times 3 is 12. 12. So I did 12 and 12 and 5.
Yeah.
She did.
I did use 12 and 5.
Write it.
I wrote the answer.
She just took
I'm telling you exactly how I factored that.
She just took the-
Okay, listen. No, I didn't. Don't say that. Whatever way works for you is the way you need to do it. Because the way you did it, I would say you made it harder. And I'm not doing that, am I?
Nope.
Okay, so I came down to 12 and 5, yes?
Yep.
Again, I know these are the factors of what?
2,
No, the factors of what?
2.
A. And these are the factors of what?
C.
C. Okay. The only factors of 2 are 2 and 1, correct?
Yes.
So I wrote 2x and x. I need to get 12. What's the only way I get 12?
With the 6.
With the 6. I put a 6 here. What's the other factor of 30? 5.
5.
I'm done. 12 has to be negative. So I put a negative and a positive. If you did the whole factoring by grouping, you should have got the same answer, right? Okay. If you need, Evan? If you need to work on factoring, please come in. We will work on factoring. But it is going to be a daily thing, guys. Okay, so x equals what?
X equals
Negative 5 halves and 6.
Negative 5 halves and 6. How do we get negative 5 halves and 6?
Divide or subtract 5 divided by 2 after setting it all equal to 0.
Okay, so we write zeros and solutions
and then the x-intercept.
like that.
Yeah,
How do I write x-intercepts?
as points, as coordinates.
So when you have on your test and I ask you for the zeros and you write them as coordinates, did you write them incorrectly?
Yeah.
Yes. Okay? Because when I say zeros, I'm already saying y is 0, so you have to tell me the x, correct? If I ask for x-intercepts and you just write x equals negative 5 halves and 6, did you write them incorrectly? Yes, you just didn't get that last simplification, that last half a point. Make sense?
Yeah.
So we need to know the difference between those. I will tell you that sometimes if I get the book going like that, I was trying to get on it again today and I ran out of time. Sometimes they'll just say, what are the x-intercepts? And they write x equals. If they're writing x equals, they just want it negative 5 halves and 6, right? Yes. So you need to be aware how a book wants it, like a computer program. It will tell you just write as an equation. Well, x equals is equation, correct? Or they'll say write as a point, and that would be the negative 5 halves 0. But for me, it needs to be always as a point for intercepts. Okay, so find the zeros of these two kind of functions. Those are fun. Okay, so I have g of x equals the square root of 10 minus x squared. Well, how do I find the zeros? I set it equal to what?
0.
Set it equal to 0. When I say find zeros, I'm asking you what x's make this thing 0, right? Okay, so I'm going to have 0. Oops, sorry. 0 equals the square root of negative x, or 10 minus x squared. So how do you get rid of a square root?
Squared.
Square it. Well, when you square 0, guess what you get?
0.
0. Okay, I'm going to square it all, and I get 0 equals 10 minus x squared. I'm going to add x squared. Anybody else with me?
Yeah.
Okay, add x squared equals 10, and then I have to take the what? Square root again.
Right.
So I have x equals plus or minus the square root of 10. Now, we got a problem. I squared this, yes?
Yeah.
You think maybe I added in an answer that might not be good?
No.
Possibly.
Possibly, right? Okay, so I need to check. So a square root looks like that.
Yeah.
Or in this case, actually, it's reflected over the y-axis, so it looks like that.
Yeah.
And then it's squared, so it has some other stuff going on with it, right? So, we got to check. Well, if I plug in positive square root, so if I square a square root, I get what? What's inside?
10.
Yes? 10?
Yes.
So I have 10 minus 10, that would be 0. Can I take the square root of 0?
No. Oh, yes.
Yes. Yes. Okay. Now if I plug in a negative square root of 10.
I think it's drawing up on the board if you're writing on your tablet.
No, I'm not.
Oh.
We're doing our head. I'm going to write this one, though. I'm going to do 10 minus negative square root of 10. Why did I specifically put those parentheses on this one?
Cause you knew.
Because I have a minus and a minus, so it's going to be a positive. So 10 plus 10 is what? 20. So it goes this way, but it comes back down, doesn't it? Because are both of these good? What would make this not good?
A positive.
Like this would be the square root of 20, right? What would make this not good?
Yes.
Like, if I would have plugged this in and this would have came out to be a what? Negative, because I can't take the square root of a negative number, right? So if it would have came out to be a negative, then I would say, okay, that one isn't good. The plus or one of them is good, the plus or the minus. Okay? So when we square something, we choose to square it, you should always take a second to see if they're both good. Because a lot of times you add something in that's not. Okay, what kind of a function do I have next?
Fraction.
It is a fraction, otherwise known as a rational function, correct?
Yeah.
So, when we have fractions, well, it doesn't matter. Set it equal to what? 0.
And then
Okay, now, anytime I have a fraction, my first step is to clear the fraction, yes?
Can't you take like the bottom by?
I multiply both sides by what? 3x minus 5, the quantity. These are quantities, please remember that. You probably should put some parentheses around them. So when I take 0 times 3x minus 5, I get what? 0. Okay, is that going to happen every single time?
No. Yes.
Yes. It is going to happen every single time. So when you have a rational function, you really only need to set what equal to 0? What is the top called? The numerator. Okay? When you find the zeros of a rational function, do I even really need to mess with the denominator? No, because every single time it's going to be what? 0. Okay, so now I'm going to add x squared. How about you?
Yeah.
Equals 4, and then what?
Square.
Square root, not square it. So x equals what?
2.
No,
Plus or minus 2.
plus or minus 2. Now, there's a big difference. So we didn't square it, did we? We took the square root. So probably both of them work, don't they?
You didn't take 4 minus x squared times 3x minus 5?
Well, I did in a reduce.
Oh, yeah, you're right.
no, it's
Yeah, the point of that is they're reduced, right? I mean, I don't want to make my problem ugly, like gross.
Like Evan.
No.
I was gonna say that, but I thought you should.
Evan, be nice to yourself. Okay. So those are the two types of equations people struggle with most. Okay? So that's why we did them. And are you going to have some square roots and rational functions?
Yes.
Yes, you do. Okay, increasing, decreasing, and constant. Okay? From left to right. Left to right. Always. It's going to jump on me because I didn't put my pen on. Okay. It is from left to right. I wish the highlighter highlighted. Watch this. This is the highlighter.
You have a phone call.
Thanks. You guys be writing while I answer the phone. Okay, so we did this last year, and I am going to bring it up. Every time we did it last year, I expect you to, at least when you see it, go, oh, yeah, we did. Okay, I don't expect you to have mastered it, but do I expect you to say, okay, yes, we did that? Yes. Okay, left to right, you're walking down the street. This graph, is it going up or down? Down, so it's what? Decreasing. Then it goes what? Constant, and then it goes what? Increasing. Okay, so the intervals of increasing and decreasing on here. So intervals we write in interval notation. So when you get a graph, this is what I do. And I you don't have to do it, but this is what I do. I just write increasing, so INC and DEC. For what? Increasing and decreasing. I start from the farthest left. This one does not start at negative infinity. How do I know that?
Because it has a point.
It has a close point. Where does it start?
At negative 2, 4.
At negative 2. Intervals, listen to me. other than range, all intervals are only x values. Understood? The increasing and decreasing is what the y's are doing. Okay? Do you get what I'm saying?
Yeah.
Okay, so -2 to what? Is this
0.
0? So it is doing what? The graph is going what? Decreasing. So you put on decreasing parentheses -2, comma 0 parenthesis. Why did I not use brackets?
Because it's not
No
a
stopping
open
point.
circle.
Nope, has
Cause that's
nothing.
not the
Confused on why
points.
you use 0.
Okay,
It's the-
at-
the-
First of all, at 0, does this change from decreasing to constant?
Yes.
So from -2 to 0 on the x-axis, the y's are decreasing. Okay? The interval are x's, and we're talking about the what?
Why?
Y's. Okay? So, at that point, at -2, 4, is this graph increasing or decreasing? Right at the point.
It is. No.
No, it's doing nothing. It's constant, yes?
Yeah.
Okay? What about at 0, 1?
It's
No.
It's switching from decreasing to
Constant.
constant. So the endpoints are not included. Make sense?
Yeah.
Okay. Now, oh, we forgot constant. Normally it doesn't have a constant, right? Okay. So then we pick it up. 0 goes to constant, yes?
Yeah.
0 to what?
0 to 2.
0 to 2. And again, we're talking about, we state the x's and the constant or what the y's are doing. Okay? Then 2 to what?
2 to 4.
2 to 4. Why is it not infinity?
Because there's
But
a
it's
solid point.
There's a solid point. From 2 to 4, it's doing what? Increasing. Now we're going to talk about positive and negative also, and that's two different things. Okay? Left to right, what is the graph doing? If it's going down, it's decreasing.
It's going up.
If it's going up, it's increasing. And constant is kind of self-explanatory. Okay. So, intervals of increasing and decreasing, or constant. Are there any constants on here? No. So before I even start, I'm just going to write increasing, decreasing. Okay? And I'm going to just go left to right. Well, my left starts where? Austin, put your chair down. Evan, put your chair down. One of them is broken already from people doing that. You need to stop or I will have to bring back the little desks. I'm done. Okay. Where is this one starting at? Negative infinity. Okay? So at negative infinity, then where's it going?
0.
It's going what? Up or down? Up. So that's increasing? Okay. So increasing from negative infinity. Now, at this maximum is where it changes, correct? Right? I should be writing on the here. At this maximum is where this changes. Increasing and decreasing is always going to happen as a relative minimum or maximum. And I use the word relative because can we start having more than one happen?
Yes.
Yes. Okay, so negative infinity to what? 0. It is increasing. Now 0, it then better jump to decreasing, right? 0 to what? 2. Oop, I didn't stop because it's right here. To 2. Okay, and then jumps to increasing.
Would you put the unit?
No, you would. No. Because you're not talking about a domain or anything. I know some people would, I wouldn't. Okay, 2 to what?
Negative. Or no, it's
Positive infinity.
And beyond.
Okay, so in this case, I started and stopped with negative infinity because this graph goes on forever, yes? Did I leave any gaps? Is there any gaps in what I did? No. And also, if I have 0 increasing and decreasing, it can't be doing both, can it?
No, it's
Because if it's increasing and decreasing, it's just stable, it's constant, it's not doing anything. Make sense? Okay, so these intervals start and stop at what are these called? What are these things called?
Roll back to back.
relative minimum and maximums. Okay? In intervals of increasing and decreasing start and stop at minimum and maximums. Or relative. I always leave off the relative, but it's there. Okay, so what about this one? What's this graph doing? X cubed.
It just increases.
It's just increasing. It looks like it's flat right about here, but if I zoomed in there, would it really be? No.
Increases
So this
from
is just
negative
increasing
to positive infinity.
from negative, that's a parenthesis, negative infinity to positive infinity. Okay? Well, this one, I've got a max here, and then I got a min here. So it's going to be doing what? Increasing here, then decreasing here, and increasing here. And it's going to happen then at -1 and 1. Do you see those intervals now?
Yep.
You see it broke up? Now what's going to happen on the next one? It's a piecewise function. Look at that.
It's gonna increase.
It's increasing here,
So to 0.
Constant.
Constant.
and then it's constant,
From 0 to 2, and then it decreases from
and it decreases here.
infinity.
So we have this interval, and what?
That interval.
This interval.
I have a question.
Yes.
So on the second graph, would it start with negative infinity
Yeah, it would be negative infinity. So increasing, let me go here. Decreasing.
till is that
So increasing negative infinity to
-1?
-1. And then -1 to 1. And then 1 to
-2.
positive infinity. Make sense?
Yeah, this stuff is kind of easy.
Yeah.
to understand.
Oh, it is 2. Okay. I think we only have like 1 or 2 more slides. Okay, relative minimum maximums. We already talked about it. Why is it relative now instead of just min and max?
There could be more than one.
Because there can be more than one. Relative means relative to the domain or the interval on the x-axis. That's it. Okay? So really, is relative min or max any different than a min or max? No. It's not the min or max of the equation anymore, is it? It's a. That's all it is. It doesn't, we put an A in front of it now instead of a. Okay, wait. Because this one, you shouldn't even write down much on this one. Rate of change, what is rate of change? Slope. Rate of change is slope. So average rate of change is the slope between 2 points. Okay, so this line, this curve you see here, that is not linear, is it? Does it have a constant slope?
Yeah.
Does it have a constant slope? No. So then we find the average rate of change. So we find the average rate of change right here. So we draw a line through 2 points and use the slope formula. That's it.
Okay.
So average rate of change and slope, is it really any different? No. The only difference is the curve that you're finding on, is it constant? No. Okay. What is the slope formula, guys?
M
X2
equals
Negative.
y
minus
y1
y1
over x squared, or x2 minus x1.
Okay, if you don't remember, make sure you got it down. Okay, Monday we're going to answer questions on this. I don't think the rest of it is just examples on using the slope formula. I'm pretty sure you can use the slope formula, correct? I will tell you directions. Please look real quick. I think some of you have noticed already you're getting confused in the directions. I give you an equation, x cubed minus 3x. See that? And I want x equals -1 and x equals 0, or x equals 0. So I gave you the x's, I gave you the equations. What do you have to find? A y?
And then the
How do you
average.
find a y? Plug in, no. Plug in the x's they gave me. They do that a lot. They give you a function and they only give you an x. You have to find your own y. Got it? So make sure you're using all your resources this weekend. Hopefully it doesn't take you too long because you started last night.